Now, the last piece of asset that I want to talk about in power distribution is a very unique one. So it is not an equipment per se. It is actually a piece of land. A piece of land for which the utility company install its asset on. But it is still owned by the utility and people cannot build on it because it is the utility's land so that they could install their own assets to provide power to its customers. So in this case, let us look at the utility right of way, and we actually have a method on applying asset health index to this special type of asset. So let us start off with degradation. Uncontrolled growth and the encroachment of tall vegetation, such as coniferous and deciduous trees within the safe line envelope, are common examples of right-of-way degradation in the case of overhead lines. The upkeep of floor vegetation that is incompatible with overhead utility lines is a constant challenge. Other natural degradation modes of the overhead power lines right of way include soil erosion, which reduces the minimum depth of buried cables, ponding at pole bases, which accelerates pole rotting, and bush development under the lines, which increases the risk of wildfires inside the right of way. Construction of ancillary buildings and structures which compromise clearances could be another form of degradation. Planting of shrubs or trees too close to patent-mounted equipment, excavations within the right-of-way compromising the minimum required clearance on top of the buried cables, and soil cave-ins resulting in damage to duct banks during construction by third parties within or near the right-of-way are the main degradation modes for underground distribution lines. In comparison to the front lot right-of-ways, the back lot right-of-ways often degrade faster over time. Now, under normal system operating extremes, overhead power lines at all voltages require space from other objects to avoid flashovers to earth, other equipment, or humans. The following are examples of the extremes as shown in front of you right now. So the most severe one is extreme sag, which occurs when a line is operated at its maximum thermal load, namely where the conductors are taking their maximum allowable current load. The other extremes is extreme swings of the power line, which occur when winds force conductor and insulator movements up or down or even sideways. Another extreme is when it is at a highest flashover voltages, which occur when conductors carry lightning surge currents that can damage trees or other nearby objects by causing voltage breakdown. A fourth one is an extreme of snow or ice loading in some seasonal conditions, which causes the anticipated sag of tree branches fall into lines. And speaking of branches or trees, the bending of trees into lines due to wind is also another of the issue. Next is the formation of lines of bushes or trees within flashover distances, which will impede and posing issues to an overhead line in its right of way. And lastly, the falling of trees in such a way that part of the tree infringes on conductor clearance during or after the fall, regardless of the circumstances, would cause problems for the right of way. Now, a right of way, unlike other distribution system assets, does not have a fixed life or expected end of life, because this is a special type of asset that's just a piece of land. And in order to accommodate distribution line assets in perpetuity, rights are purchased and held by the utility company. And when the utility acquires alternative circuit routing, a distribution right-of-way may be relinquished and the area be abandoned by the utility company. When trees or bush growth extends within the safe electrical clearance envelope, the right-of-ways become poor or very poor condition in the case of overhead lines. When minimum clearances to the ground or grounded objects are violated, or when the structural integrity of the pole is endangered owing to soil erosions or ponding near the pole bases, bad or very poor circumstances might occur. And when a utility's access to the equipment for maintenance and operating activities is blocked, we will assign a condition of bad or very poor in the case of underground cable right-of-ways as well. The distribution right-of-way condition is actually determined not just by the time since the last clearing of the trees or bush, but also by the following factors as shown in front of you, which are, first of all, the bush control method employed, such as mechanical, manual, herbicide, or a mixture of all three, the cutting and management of trees and shrubs, the landowner's agreements, the tree vegetation species that are surrounding the right-of-way, the climate and the growing conditions in the area, so we're talking about geographically. The land under near the power line is how is it's being used, as well as the trees at the right-of-way can be weakened by forest fires, other animal activity, root rot, insect kill, unstable soils, as well as long exposure. Tree densities within the right-of-way can also have a significant impact on right-of-way maintenance expenses. Tree growth and density, if not properly maintained, might necessitate extensive upkeep. Trees that fall into the right-of-way from the edge can also cause outages. Edge trees, as a result, require explicit assessments to establish their condition and potential impact on the distribution system reliability. Now, before we move on further into our course, let us take a brief look at our sponsor for this course. Now, as an engineer, especially when I first started in my career, I really felt overwhelmed the list of documents that we need to do on top of our technical work. Yet, these documents are very important in our career as it is the more prominent thing that displays our credibility to management and to our clients if we so decide to become an engineer consultant, which is where the real actual money is. Now, I don't have these tools available to me when I first started my career, but now PM Milestone has created this package of all the professional templates that you need so that you can focus more on the technical aspect of your career. These templates are tried and tested by real professionals, so you should feel confident in using them in your career to present your best foot forward in front of your manager or clients. These templates are also updated periodically, and I think their last update is just 2021, so they're not going to be out of date or context to the present times, as these people are serious in getting the most professional product to meet your needs. They're also very confident of the quality of these templates too, as they offer you their product completely risk-free with 60-day money-back guarantee if you are not satisfied with it. So, if you are interested in this product and would also like to support me in creating these courses on YouTube in the future, please check out their product using the link in my video description titled Course Sponsor PM Milestone 2.0. In general, the right-of-way assessments take into account of the state of the vegetation around the right-of-way corridor, the condition of the vegetation along the right-of-way corridor's margin, and the state of the vegetation on the lands directly adjacent to the right-of-way. Now, inspection-based vegetation management strategies are the most effective. Visual inspection can assist and prevent degradation by detecting encroaching vegetation. The areas of where some of the most common right-of-way vegetation management techniques are used are such as herbicides, mowing of lawn, pruning, slashing, as well as removing of hazardous trees. The maintenance requirements for right-of-way in urban and rural locations are very much different actually. For example, right-of-way in densely populated urban areas may require little or no upkeep, and right-of-way in urban and suburban neighborhoods, on the other hand, may necessitate extensive care depending on nearby property uses and community standards. Right-of-ways in rural areas, on the other hand, have maintenance cycles based on the growth rates of the vegetation on the right-of-way. In general, professional arborists can estimate the number of management cycles that are required, and this technique, on the other hand, may place both cost estimation and the treatment in the hands of a single contractor, which in this case limits the utility's capacity to regulate its expenses. Independent inspection and monitoring approaches can provide more extensive assessments, but right-of-ways including a forecast of tree or bush development over time. And this can increase reliability by forewarning of unforeseen problems that can be addressed sooner rather than later, or by signaling that treatment can be safely postponed. So, in other words, it would save money. Managers must consider whether the entire electrical system length should be treated as one unit for a time-based maintenance policy, or whether an inspection or condition-based system should be used to establish maintenance priorities based on the risk of faults when optimizing the budget for right-of-way maintenance cycles. Treating a length of electrical system as a single unit has the advantage of allowing maintenance to be based on an easily detected fault incidence record. Establishing risk-based priorities is more difficult than evaluating fault occurrence records, but it may be more cost-effective in lowering overall fault conditions or occurrences. So now let us go over the different categories that make up the health index of the distribution right-of-ways. Let us first start with tree clearance. Now, with all the categories for right-of-ways, we actually only have 3 ratings, which are 4, 2, and 0. So for a rating of 4, it means that the horizontal and vertical clearances of the trees are within limits. For a rating of 2, it means the horizontal or vertical clearance are close to the recommended limits. And for a rating of 0, it means that the clearances horizontally and or vertically are deemed unacceptable for this right-of-way. The second category is tree overhang or hazardous trees. For a rating of 4, it means that the overhangs are acceptable with no risk due to tree overhang. For a rating of 2, it means that there is a moderate risk due to overhang or hazardous trees, and it requires closer attention. And lastly, for a rating of 0, it means that there's a high risk for tree overhangs or hazardous trees, and this requires immediate attention. The third category is tree density. So for a rating of 4, it means that the tree density is considered low and therefore it is acceptable for the right-of-way. Rating of 2 means it is of medium density and it requires close attention. And for a rating of 0, it means it is high density and it requires immediate attention. So what do you mean by tree density? Well, tree density means like how many trees are within the vicinity or within the right-of-way in general, and how much is considered low, medium, or high. Well, that really depends on the standard of your region. So basically, if you actually have a question about this, you should consider the standard that governs your region of your utility company. The fourth category is vegetation height and density. So for a rating of 4, it means that no vegetation growth are under the lines. Rating of 2 means that there are moderate vegetation growth under the lines, and it requires paying closer attention to it. And lastly, for a rating of 0, it means that there are a lot of vegetation growth and it requires immediate attention. Then the fifth category is clearances from buildings and structures. So for a rating of 4, it means that the clearances are within limits. For the rating of 2, it means that clearances are close to recommended limits. And for a rating of 0, it means that there are unacceptable clearances between the right-of-way and the buildings. Now the sixth category is condition of right-of-way access, drainage, and soil erosion. So for a rating of 4, it means that there are no obstruction to the right-of-way access and no problems due to drainage or soil erosion. For a rating of 2, it means that there are minor issues with respect to access, drainage, and or erosion. And for a rating of 0, it means that there are serious issues with respect to right-of-way access, drainage, and or soil erosion. The seventh category is more or less related to underground lines right of way, and that is the obstructions for access to pad mounted equipment. So for a rating of 4, it means that there are no obstructions to pad mounted equipment by backyard fences, shrubs, or gardens. For a rating of 2, it means that there are minor obstructions found to the pad-mounted equipment by backyard fences, shrubs, or gardens, and this requires the utility to pay more attention to it. As for a rating of 0, it means that there are severe obstructions by things like fences, shrubs, or gardens and requires immediate attention from the utility. The eighth category is the type of landscaping. So for a rating of 4, it means that the right-of-way is sodded ground and there are low cost of excavation and refinish. For a rating of 2, it means that the right-of-way is of asphalt or paved asphalt. So that requires medium cost of excavation and to refinish. And as for a rating of 0, it means that we are using concrete or paving stone for the right-of-way, and what that means is that it has high cost of excavation and high cost to refinish. The ninth category is drainage and soil erosion. So for the rating of 4, it means that there are no problems due to drainage or soil erosion. For a rating of 2, it means that there are minor problems due to drainage or soil erosion. And for a rating of 0, it means that there are serious problems due to drainage or soil erosions. And the last category is location, in which what we're looking for is if it is near heavily traveled roads or in roads that have salt exposure. So for a rating of 4, it means that there are no problems due to salt spray and it is far enough from heavily traveled road. For a rating of 2, it means that there are minor problems due to salt spray and the location is close to heavily traveled road. And for a rating of 0, it means that there are serious problems due to salt spray and the location is very close to heavily traveled road. So now let us look at the health index weights of these categories that composes the health index. So as I've gone through the categories, some of them are actually for rural lines only, some of them are for urban lines only, and actually some of them are for underground right-of-ways only. So let's go over each of these. Now, for overhead right-of-ways, all of those are assigned the same weight, so that's why we're assigning all of them to a weight of 1. So in this case, there are tree clearances, overhang or hazard trees, tree density, condition of access drainage, and soil erosion. Now, if your right-of-way is in a rural area, you count the brush height and density, and if your right-of-way is in the urban area, you account for the clearances from buildings. So now let us look at the table to the right, which is the underground right-of-ways. So in this case, we got around 4 categories, which is obstructions for access, landscaping, drainage, and soil erosion, as well as location near heavily traveled roads with salt. So basically, we will look at landscaping and location where we're given more weight. And basically that the main reason for these is actually more or less because of the cost for excavation. So landscaping, depending on the type, it'll be costly or it will be cheaper. Same as if it is in a heavily traveled road, it means that you need more closure or permits to actually maintain that right-of-way or excavate the line for maintenance, etc. So that's why we put those as a higher weight than obstruction for access and the drainage and soil erosion. So now let us go over the one last example for this course. Consider a right-of-way for underground distribution where upon inspection there are minor obstructions such as shrubs or gardens along the right-of-way, which means that we assign a rating of 2. The right-of-way is of sodded ground, so it's good. So we put a rating of 4 to that. And then there are minor problems due to soil erosion from gardens in proximity. So we assigned a rating of 2. Lastly, this right-of-way is very far to any heavily traveled road. So it's good again. So we assigned a rating of 4. calculate the health index for this right away. So, as with all examples, we first calculate the score that we have for this asset, which is the rating that we jot down from the problem, multiply its respective category weight, and then you add all of those together. So in this case, it equals to 20. And then we calculate the maximum achievable score, which is the maximum rating, which is 4, times the sum of all weights. So that equals to 24. Health index equals to score calculated divided by score max times 100. So it's 20 divided by 24 times 100, which is equal to 83. And as mentioned in the fundamentals, a value between 70 to 85 is considered good, and as such, there might be deterioration of some components and only normal maintenance are needed. Now, if you like this video, please don't forget to click like and subscribe to our channel. Our channel, the EE Bootcamp, has a wealth of knowledge regarding to the energy industry, so be sure to check it out. Also, this video is part of a playlist of the whole course, and so I've put the link to the playlist for this free course in the video description. As you may be aware, I'm a professional online instructor that teaches various topics regarding to the energy industry and offers certificate of completion at the end of each course. As you probably have noticed, this course needs fundamental knowledge in basic asset management. Physical asset management is important, and the skills are highly sought after in many large companies within the energy industry, or any industry that manages large asset in infrastructures for that matter. If you lack knowledge in physical asset management, look no further than my Physical Asset Management Fundamentals course offered at Electrical Engineering Portal, as in that course, I will provide you with the fundamentals that you need to kickstart your career in the physical asset management world. Another type of knowledge that you need for this course is fundamental information about the power distribution system. If you don't have enough experience in the industry, I would suggest you to enroll in my Distribution Power Engineering Fundamentals course hosted on Udemy, as in that course, I will walk you through the different parts of the power distribution system as well as basic design concepts that you will need to kickstart your career in the industry. Now, I have put the links to both of these courses in the video description also. Lastly, I have also included the link to my website in the video description that contains the information to all the courses that I offer, as well as other helpful resources that you may find useful in your career or in your learning path. Thank you, and I wish you good luck in your career. Remember, knowledge is power.